Great. So last thing we did wave optics. Today we'll start off with ray optics. Let's say we have a mirror, y is equal to x cubed by 3. The light ray hits the mirror and bounces off like this and makes 120 degrees. Find the coordinates of point P. Just give it a try. Initially, the light ray is horizontal. Horizontal ray parallel to x-axis. So how do we do this? So from here, if you drop a normal, and if you draw a tangent, this angle will be 60 degrees. So this will be 30 degrees. So slope will be dy by dx is equal to tan 30. Dy by dx will be x square, which is 1 by root 3. So x is equal to 1 by 3 to the power of 1 by 4. From there you get y coordinate. Easy? Find the number of images and the position of images. Others, do keep your cams on. You guys remember the process? You guys remember the formula 360 by theta minus 1 in that there are conditions? Forgot. Should definitely go back and revise this. This was a general formula if you remember. If the number is even, then it is 360 by theta minus 1 independent of position. If the number is odd and if it is on the bisector, then 360 minus theta minus 1. If it is not on the bisector, 360 by theta. Check out this page 31 there. And this is how you solve. Remember? Alpha, theta, theta, 2 theta, and so on, this crisscross thing. You should check it out in case you forgot. You don't remember, go back to the recording. You can check out in the recording there. So how do we do this? So we have M1, M2. So where is the first one here? 0, theta. So 20 and theta here is 50 degrees. I'll tell you what it means. So add 50 to this, it becomes 70. Add 50 to this, it becomes 120. Yeah, add 50 to this becomes 170, and you'll stop once you cross, you don't exceed 180 or equal to 180. You stop here. Similarly here, this is 30, add 50, this becomes 80, 80 becomes 130, 130 becomes 180, you don't count 180. So what is the meaning of these angles exactly? The meaning of these angles is this is M1, this is M2, this is the object. Okay. And this angle is 20 degrees. Now look at this. The first image in M1, so this is the number 1 image. So I'll just name them. Let's call this is the first image, right? This is the second, this is third, this is fourth, this is fifth, this is sixth, this is seventh. So how to read this? The first image will form at 20 degrees from M1. That is how you read. You're getting it? So the first image of this will be 20 degrees from here. That's your first image, 20 degrees. Now this image will create an image again in M2, isn't it? How much is that angle? So if you ask M2, where is image 1, it will say what? It will say the image 1 is making 50 degrees plus 20 degrees, 70 degrees. No? So the image 1 will form an image 2 in mirror M2. Are you getting how to understand that? The image in M1 will form an image in M2. So this is forming an M2 mirror side. So this image will create an image somewhere here, 2, which is making an angle 70 degrees with M2. So this is 70. Then image 2 is creating an image, third image, in mirror M1, 120 degrees from M1. So from M1, 120 degrees. That will be 3. So this angle will be 120. Then this third image is creating a fourth image in M2, which is making 170 degrees with M2. So from M2, 170 degrees. This will be 4, and this angle will be 170. Are you getting how to do this? That is how you keep getting angles. Now, where is the fifth image? The fifth image is 30 degrees from M2. So that would be somewhere here. Fifth image, 30 degrees. Fifth image is creating a sixth image, which is 80 degrees from M1. This is the sixth image. And the sixth image is creating a seventh image, which is 130 degrees from here. So that would be somewhere here. So something like this. And if you actually join all of them, they'll be on a circle. Clear with this? So if they just ask you number of images, use the formula. If they ask you to locate the images, right, and then you should know the angles. Little work, but do check out the notes again in case you forgot. I'm sure most of you forgot. When I was telling you theta plus theta, then you're thinking. And remember, there's one more condition. The final angles which you got, if 170 plus 120 plus theta, if it is 180, the last two images overlap, right? Because if 3 and 4 fall at the same place, we'll get 180 degrees. So you count that as only one image. Now, in this images only, there's one more thing. If you remember, what if I have two mirrors where this is the object, the mirror is exactly broken here. How many images will form? Meaning if you extend them, the mirror would have been 90 degrees. Number of images. This is another standard one. Normally for 90 degrees, you should have got three images, but here you'll get only two. I hope you remember. Because every light ray that hits M1 will bounce off here. Not a single light ray will go from M1 to M2. Remember that? So the image which forms in M1, that is I1. Now see, normally what would have happened, when there is a mirror here, the light rays from M1 would have hit here and would have gone to M2. So M2 used to think I1 is also an object. Are you clear with that? But now, since there is no mirror there, every light ray will just go off like this. Not a single light ray will come from M1 to M2. Similarly, not a single light ray will come from M2 to M1. So M2 does not know who is I1, M1 does not know who is I2. So I3 will not form. Clear? You get only two images. So rays from M1 do not reach M2 and vice versa. Clear with this? We have a mirror, angle theta. We have an object going with velocity v minus v I cap. Find the velocity of the image. I want I cap j cap. So we have a mirror at an angle theta with the horizontal object is going with minus v I cap. Find the velocity of the image. Particle is projected with even theta. It's going in a projectile motion. Gravity is there. We have a mirror here which is going with Vx and Vy. This is constant. Find the velocity of image. Mirror is going at an angle. The object is flying like a projectile. Find velocity of image in both the cases. Mm, right, Aditya. Yeah, the second one also. So how to do the first one? So see, so when the object is going in this direction, can I say like this? The image, it is symmetrical, isn't it? So the image will also try to come towards this point. Let's call this point A. So the image will also try to come towards A because it is symmetry. This is the angle theta. Is that making sense? The object and the image will try to go towards that point because see, they always have to maintain this distance. They'll actually form a congruent triangle. I didn't draw it up to scale, but there. So the object and image will make angle theta with the mirror. So the image is making, it's going with the same speed v, and it is making an angle 2 theta. So velocity of the image will be minus v cos 2 theta I cap minus v sine 2 theta j cap. Is that clear, everyone? The object and the image both will go with an angle theta with the mirror, and they will meet at that point. When the object comes there, image will come there. What about the mirror thing? This thing I told you, whenever a mirror, the mirror moves, stop the mirror. Now, here, when you stop the mirror, there's something you need to understand, that Vy is useless. Vy won't matter. Why? Think about this. If there's a mirror in front of you, and if you're standing in front of the mirror, and the mirror is going with some speed v parallel to the mirror, what happens to your image? Your image will not go away with the mirror, right? The image will be always in front of you only. Are you clear? If the image goes away, it is a ghost. Clear? Only velocities along the normal will matter, right? Vy won't matter. This does not affect the image. I hope everyone is okay with that thing. Only the mirror ka Vx will matter. So that means you can replace the problem with Vx. So at any point this particle is flying, what is the velocity? U cos theta. Vertical thing, U sin theta minus gt. Stop the mirror. Take the observer, put him on the mirror. Now the mirror will think this guy is coming with U cos theta plus Vx. U sin theta minus gt. This is the object. So the image will also go with U cos theta plus Vx and U sin theta minus gt. This will be the answer with respect to the mirror. So velocity of the object with respect image with respect to ground will be velocity of image with respect to mirror plus velocity of mirror with respect to ground. So this will be minus of U cos theta plus Vx I cap plus U sin theta minus gt j cap, and mirror itself is going with minus Vx I cap. Clear with this? Clear? You know how they can frame this question? They will do something like this. They will say there is a block here of mass m which is coming with speed u. There is a mirror also of mass m. E is equal to 1 and this is smooth. They will say find the velocity of the image before and after collision. Can you do that? Find velocity initially at rest. Find the velocity of image before and after collision. Yeah, you can mix up collisions with this. Or they can ask you find the ratio of speed of the image before and after collision. So there are ways to play around. See, initially what was the answer? Before collision, it's like a mirror. Object is going with you. Image is also going with you. Velocity of the image minus ui cap. After collision, they'll exchange velocities. Object comes to rest. Mirror is going with you. So when you go with the mirror, what you do? You go and stand on the mirror. Then the mirror thinks object is going with you. So the image is going with you. But remember, this is the velocity of the image with respect to the mirror. So velocity of the image with respect to ground will be velocity of image with respect to mirror, that is plus ui cap, which is 2 ui cap. If the mirror moves, you get double the speed. Clear with this? So be careful with that. They might look same, they're not. So before and after collision, the velocity of the image changes. Simple question, but people get trapped. They think, it is same. It's not. Similar thing. Suppose, let's say we got a disk. This is a mirror. This is a point A. This is 30 degrees. The ring is going without slipping. Find the velocity of point A, image of point A. Or let me ask you like this. Find the relative velocity between the object and the image of point A. This is a rolling ring between A and its image. So we have a ring which is rolling on a mirror without slipping. I'll not give omega. You can find that. Radius is r. The point A is at an angle 30 degrees with the vertical. At this instant, find the relative velocity between the A and its image in the mirror. Rotational mechanics. Optics. V by 2. We have V. We have two answers. Try another 30 seconds. Let's see. First, you need to find the velocity. How to find velocity of a rolling thing? Now, this body has both translation and rotation. We use principle of superposition. Because of translation, the velocity of center mass will be this way. And because of rotation, this will be r omega. That is also V. This is making 30 degrees. So this is 90. This is 60. So this is also 30 degrees. So if you actually look at A ka velocity, this itself is a question. Find the velocity of A. This will be V plus V cos 30. And this will be V sin 30. This is how A is going. And this is the mirror. The image will be going towards itself with V sin 30. And the horizontal velocity will be same, V plus V cos 30. So relative velocity will be 2V sin 30. Easy? Clear with this. What if I ask you relative acceleration? What will you do for that? The ring is going with constant velocity. If I ask you relative acceleration, then what will you say? Even though it's going with constant velocity, it will have centripetal acceleration omega square r. Remember, the particle going in a circle will have centripetal acceleration. So it will have a vertical component, omega square r sine 60, omega square r cos 60. So omega square r sine 60 ka 2 times. That will be your acceleration. So be careful. Just because it is going with constant speed doesn't mean it will have a constant acceleration. There are 3 accelerations if you remember. A center of mass, A tangential, A centripetal. So a point on a rolling body will have 3 accelerations. Find x if the final image is on the object. These are some important good questions if you remember. Find the x if the final image. Now, when you get the final image, light rays will go through the lens, one image. That image will form an image, mirror, and that will again go through the lens, and then you should get an image. So lens, mirror, lens. When they say final, it is after all reflections and all refractions. These questions are important, even at an advanced level. Let's see. So first find the focal length of a lens. Hope you remember the focal length of a lens formula. I didn't give you anything, so take the vacuum outside. So 1 by f will be mu lens by mu medium minus 1 into 1 by r1 minus 1 by r2. Hope everyone remembers the sign convention. We follow the sign convention where the direction of the light rays is positive. So here we'll get 1 by focal length, mu length is 3 by 2 minus 1, that is 1 by 2. That's 1 by 20 and 1 by 10. The R1 will be 1 by 10 minus of minus 20. That's 3 by 20. So focal length will be 40 by 3. Then use the lens maker formula 1 by V minus 1 by U. U is minus 30 and 1 by F is 3 by 40. Numbers are not great, right? So 1 by V is equal to 3 by 40 minus 1 by 30. Right? Did I mess up something? Fine. This looks fine. Then take out 1 by 10 common. That will be 339. 9 minus 4 by 12. That is 5 to, not bad actually. We use 24 centimeters. So now there are two possibilities. So this image is forming at 24 centimeters. Now two things can happen. This case 1, I is at center. That means this distance will be 20 centimeters, and this will give you x is equal to 44. There's a case 2 where I is at the pole. If the light rays go and hit the pole directly, even then the light rays will retrace, isn't it? They will not exactly retrace, they'll do something weird. The light ray which goes from the top hits this thing and comes from the bottom and reaches here, because this angle and this angle are equal. The light ray which goes from the bottom will go to the top and come back here. So the image gets inverted, but it falls at the same place. This is the second possibility, where the image hits the pole. The eye is at the pole. So in this case, x will be 24 centimeters. So both are right answers, 44 and 24. Because we're taking a point object. Clear with this? Twenty centimeters. Here we got a thin rod. This is also 20 centimeters, and this is the length of the rod L. Case 1, L is also 20 centimeters. Case 2, L is equal to 2 millimeters. Find the length of the object. Length of the image. Now, one good thing about ray optics, right? If there is a certain technique we used in mirrors, the same technique will be applied in lenses also. The techniques will be same. The formulas will keep changing though. So there, one object in the first case, the length of the rod is comparable to the radius. Second thing, it is too small. So two different questions. How do you handle them? Again, like I said, the process is important. You can solve it. Maybe it will take a little time, but how do you handle both of them? And the length is big and length is small. Try. I'll give another 2 minutes and then I'll show you for both. Okay. Let's see. The first part, actually, the second part is more easy. So in the first part, when length is 20 centimeters, so I'll just make the rod a little bigger. Let's call this thing A and let's call this thing B, and this is also 20 centimeters. So just find the image of A and B separately. So A ka image will be 1 by V plus mirror, na? It's a plus formula there. 1 by U is minus 40. Here focal length will be plus 10. You will get Eka image. How much is that? 1 by 10, 1 by 40, 8 centimeters. Similarly, do it for B also. 1 by V plus 1 by minus 20 is equal to 1 by 10. V will be 20 by 3 centimeters. So we got two images there. So this is A dash and this is B dash. So all the remaining points must be between this. And this guy is 20 by 3 and this guy is 8. So the difference must be the length of the image, which is 8 minus 20, 4 by 3 centimeters. Clear with this? So you find the two extremes and everything else must be between them. So subtract them. That is it will work. Now when length is very small, 1 by V plus 1 by U is 1 by F. Differentiate. So when you differentiate, this will become minus dV by V square minus du by U square is equal to 0. So dV is what? Ask yourself, what is V? V is the distance of the image from the pole. What is dV? dV is the distance between the two extremes, isn't it? du is the distance between the two extremes of the object. Then dV will be the distance between the two extremes of the image. So dV will be du into V square by U square. So here du will be 2 mm. V and U, you can use 20 centimeters and finish it off. Clear with that? So the second part, for small objects, you use differentiation. For big objects, you find the extremes and finish it off. All clear with that? You can get the values there and substitute. Same question. Let's say we have an object which is going here with a constant speed from infinity. Object moves from x is equal to minus infinity to pole. Can you draw the path of the image? This we did. It's a pretty good one. Same thing. An object is going in front of a concave mirror. It is going from minus infinity till the pole. It hits the mirror. Paraxial rays. Draw the path of the image. So object is traveling above the principal axis. Draw the path of the image. This is a more of a theoretical one. Think, I'll give a minute. Let's say. Now for this, you need to know the image formation. Yeah, how will the images look? So let's start from there. So instead of directly doing this, let's do like this. Imagine we have arrows here. We have arrow here, we have arrow here, we have arrow here, we have arrow here, and we have arrow here. So there are like 5 arrows. So ask yourself, where is the image of arrow 1? When you're at infinity, where will the image form? At the focus. So it will be point 1 will look like a point. Where will 2 form? 2 will be closer to the pole, but diminished. 3 will be still closer to the pole, diminished, but little better. 4 will be like this, and 5 will be exactly same height. So if you join all the heads of this, isn't that the path? Are you clear with this? So I can even ask a better question. If you take a convex mirror and if you put a square in front of it, if you take a cube or a square, they'll ask you draw the shape of the image. If you put a square in front of it, how do you think the image will look like? This is how the image will look. You will not get a square, you'll get something of this sort. Making sense? So you put in, multiple arrows there and do that. Can you do the same thing for concave also? No, concave is a pretty good answer though. Convex is easy. It will not go in a straight line. These things will go at angles. You can see the velocity here, how it is going. So eventually the velocity rate will become like flattish. As you go closer to the pole, it becomes more flattish. So any object that you keep in front will actually look like this. That's not a rectangle, nothing. You can't find that area. Can you do the same thing for concave? If an object is coming from infinity towards the pole, how will the image be in a concave mirror? Hmm, this is a good one because this thing even creates a virtual image. The previous one, all are virtual only. Here you get a real also. So let's put some arrows here. So let's say we have an arrow at infinity. So this is the center. This is the focus. This is the pole. Now it would matter where is the arrow. This is here, beyond center, at center, between center and focus, at focus, between them, at pole. So 1, 2, 3, 4, 5, 6, 7. Can you tell me where will be the image of 1 be? If the object is at infinity, image will be at focus 1. 2 will be if the object is beyond center and infinity, image will be between center and focus and diminished, but inverted. This is 2. 3 will be exactly under this. 4 will be somewhat like this. 5 will be at infinity and magnified. So if you join all these heads, that is how will the velocity be. Once you cross focus, what happens? Again, at focus, the image will be at infinity. So there is one more arrow here at 5. And then 6 will be again inverted somewhat like this. And 7 will be of same height. Clear with this? As the object is coming from infinity till focus, it will be a real and it will go from focus to infinity. Once you cross the focus to pole, image becomes virtual. It will come from plus infinity towards the pole. Is the path clear, everyone? Clear? We have an object here going with 2 centimeter per second at a height of 1 centimeter at a distance of 30 centimeter. Find the velocity of the image. Mirror itself is also going with 3 centimeter per second. Find velocity of the image with respect to the ground. This is a good one. If it's a mains level question, they will mostly keep the object on the principal axis and they will keep the mirror at rest. I moved the mirror, so we made it tough. I kept it above the principal axis. I made it tough. I can make it even more tough. I can make it go at an angle of something. That will be the ultimate thing. But okay, let's not push it so much. We'll see that later on. Let's get this. Try. You got 2 minutes. This is what I'm saying. The moment you see the question, you should know what to do. If you, in a mains exam, if you think I will go to the exam, I will see the question and I will think and solve, you're gone. Out of 25 questions, at least 22 to 23 questions, the moment you see, you should know what to do. 2 to 3 questions you can think. Try. Let's see. Let me show you the deadly one. So first thing, if a mirror or a lens moves, stop it. That is the first thing you need to understand. Something is moving, stop that thing. Right? Once you stop that, life becomes a little easy because you have to deal with only one thing moving. So if you go and stand on this, let's say this thing has a velocity Vy, and let's say this thing is going with Vx. Now we also have a mirror, so let's call it Vm. Right? So whatever is the velocity of the mirror. And then, yeah. So drop the perpendicular, you know that stuff. So 1 by V plus 1 by U is equal to 1 by F. You can calculate that V ka value from here. Now for the velocity, 1 by V plus 1 by U is 1 by F. Differentiate this on both the sides. Minus 1 by V square dV by dt minus 1 by U square du by dt minus 1 by F square dF by dt. F is constant, so this guy goes off to 0. So we get du by dt is equal to minus V square by U square du by dt. Now be careful. What is U and V? U and V are distances measured from the pole. So when you differentiate V and U, you get relative velocity. You don't get velocity in the ground frame. This is velocity of the image with respect to the mirror. That is one mistake people do. If the mirror is not moving, you generally don't have a problem. Because U and V are measured from the mirror. These are velocities with respect to the mirror. Are you clear with that? Be very careful with that. These are not velocities in the ground frame. So now you know v ka value, u ka value. You can dump that v square, u square, and this guy will be vx plus vm I cap because it's going in the direction of the light ray, and you get velocity of the image with respect to the mirror. But remember, this gives only the x component. This gives you only the x component. This does not give you the vertical direction because u and v are horizontal distances, right? So velocity of the image with respect to the ground in the x direction will be velocity of the image with respect to the mirror in the x direction plus velocity of the mirror with respect to the ground in the x direction. This gives you only the x component. Clear with this, right? And then for the vertical component, what we do? We use magnification, which is equal to minus v by u, which is nothing but height of the image by height of the object. So height of the image will be minus h naught v by u. Differentiate on both sides. If you differentiate dhi by dt, this gives you velocity of the image with respect to the mirror, but mirror is not moving anyway in the y direction. But remember here, all three are variables. Height of the object is also changing because of vy. If there is a vy, dh naught by dt will be vy. That is also not there. So this will be minus h naught by u dv by dt. I hope you know how to do triple differential. Take one as constant and differentiate the remaining h naught into v. That will be minus 1 by u square du by dt minus v by u dh naught by dt. Not really that tough. So dump everything there, you'll get the answer. That becomes a really lengthy question and a little tougher one if it goes an up and down also. Check out in the class notes. In the class notes, we did it in a more, simply. First, I kept the mirror at rest, then I moved the mirror, then I kept it up. I did all the three cases. Clear with this how to do. But this is the main important formula there with respect to the mirror. At a mains level, general, they'll keep it very easy. They'll just keep it on a horizontal, on the principal axis. Clear? And don't mug up the formula, getting it? Because you'll not be so lucky every time. Matlab mains mein general not an issue, but advanced mein they'll do something like this. Let's say this is R, and this is R, 20 centimeters, and they'll say refractive index mu is equal to 2 plus t square. The refractive index of the lens is changing. Object is here, and this distance is 3r. Find the velocity of the image. Let's make it 2 plus t. Find the velocity of the image at t is equal to 2 seconds. And the people who mug up the formula, they'll get slaughtered here. They'll not understand what happens when that formula won't be valid anymore. So the concept is what? Differentiate the formula. That is the concept. Don't remember the results and all that stuff. I can even mess up the radius of the mirror also. So dh naught by dt, yeah, in the given question it will be 0, but if there is a vertical component, it is not. So how do we handle this? Same story. Get the formula. First of all, what is the focal length? 1 by f, mu minus 1, that's 2 plus t minus 1 by 2 by r. That would be t plus 1, 2 by r. So 1 by v minus 1 by u, which is minus 3r, is equal to 1 by f, which is t plus 1, 2 by r. Differentiate it. Minus 1 by v square dv by dt is equal to 2 by r. There, the dv by dt is your velocity of the image. The lens is not moving. You know r ka value, you know v ka value you can find at t is equal to 2 seconds. So that we get everything. Clear with this? So be careful with that. You can even mess up the focal length. Same question I can ask you in another way. Suppose we've got a lens. Let's say this is y is equal to 0. This is y is equal to 2 centimeters. Y is equal to minus 2 centimeters. The refractive index mu is equal to 2 plus y square. Make it 1 centimeter and minus 1 centimeter. So the refractive index is changing with height. And there's an object here at a distance of 3r. Find the length of the image. The mu is changing with position, with the height. Matlab this lens, right? Different pieces have different refractive indexes. So we have an object, a point object. Something happens. This you'll not get a single image, you get multiple images. Find the length of the image. So what is the catch? Because remember what happens if a lens has multiple mediums. Suppose if you have a lens, this is also a good question. Tell me what is the answer for this. Suppose if I have a lens here, let's say this is mu1 and mu2. Suppose if I have a lens here, the left side is mu1 and right side is mu2. Suppose if this is mu1, mu2, mu3 and mu4. Mu1, mu2, mu3 and mu4. Can you tell me how many images will form in each case? Because remember this, each small part of a lens behaves like a complete lens. If a lens is made of 10 different pieces, then you get 10 different images. So in this case, the light rays which go up, they will meet somewhere here. The light rays which go bottom, they'll meet somewhere here. You get 2 images. What about the second one? Even though there are 2 different mediums, understand this thing, the light rays are not unique. Whatever light rays go on the top, they'll pass through mu1, mu2. The light rays on the bottom will also pass mu1, mu2. They're identical. You get only 1 image. What about this guy? These light rays are going mu1, mu2. These light rays are going mu3, mu4. There are only 2 images. So putting a medium left, right really actually won't matter. It's only up and down. But D is a different case. You can have a light ray going only through mu2. You can have a light ray going through mu1, mu2. You can have a light ray going through mu3, mu4. You can have a light ray going only 3, mu4. They have 4 images. Clear this? So if you extend that little outside, you can make light rays go only through mu2 also. So it's always about how many unique light rays you have. Clear with this? So 2, 1, 2, 4. Again, not a tough question, right? If you actually know how to do it, will take 30 seconds. But it's a good one. So in our case here, since this thing is made of infinite mediums, you get infinite images. Then how do you do for this? So at the center, mu is equal to 2. At the top, mu is equal to 3. So treat this as two lenses. So treat this as a lens of mu is equal to 2. Find the image. Let's call it A. Then treat this as a lens mu is equal to 3. Then find the image that will be somewhere B. So you get 2 points, A and B. Mm, Where do we think I'll get? I'm not sure. You can check the values. A and B will be somewhere here. This will be the length of the image. Clear how to do that? So treat this as length of mu is equal to 2 and mu is equal to 3. Find two images. And then we can be sure because from 2 to 3, every other point should be between A and B only. I'm not sure A is front or B is front. So check it out that time. Is that clear, everyone? So these are some pretty good ones. Not tough, but theoretical stuff. Take a break. Come back by 9:40. We'll continue from here. Get away from the screen for 5 minutes, or else your eyes will be strained. There. We got an object placed in front of a concave mirror. Inside the concave mirror, there are two liquids, mu1, mu2, and the heights are h1, h2. Find D if the final object falls on the image. Final image falls on the object. D is the distance from the surface to the object. Find D if the final image is on the object. So the light rays will go through the two liquids, mu2, mu1, then hit the mirror, then again come back through mu2, mu1, and then go. Hope you guys remember, there's a general formula I gave you for slabs. You should definitely remember that. Saves you time if you know that result. Go back, revise the notes. What the formula? That's important. Where we did this thing? Reflection, huh? Parallel slabs, we started this if you remember. There. This is the general formula. See, if you have multiple slabs, mu1, mu2, mu3, mu n, and thickness T1, T2, T3, and present in a medium mu_m, and if this is the object, this observer will think the object is at a distance of h plus d1 plus d2 plus dn. So basically, these distances in the middle won't matter. You can just add them up. But see what happens to the slab. The distance of that slab becomes T1 by mu1 into mu medium, T2 by mu2 into mu medium, and so on. So basically, you can replace the slabs with T1 by mu1 into mu medium. Clear with that? So page 106, check it out. So that means in this case, what you can do, the object is there. This distance is D. You can replace this red thing with, now who is the observer? The light rays are coming from the object. The mirror is the observer. So you can replace this red liquid with H2 by mu2. Outside it is vacuum, so I'll do nothing. Then you can replace the green liquid with H1 by mu1. So if you ask the mirror, where is the object? The mirror will think this is the distance. mirror thinks object is at D plus H2 by mu2 by H1 by mu1. Is that clear, everyone? So you can assume a thin air gap between the liquid 1 and the mirror. Clear? Now you tell me. If the final image falls on the object, that means what? Light rays are retracing. If the light rays are retracing, then the mirror should think, where is the object? It should think it is at capital R, isn't it? Are you clear with this? Since the final image is on the object, light rays must be retracing. That means the mirror must think object is at the center. So mirror feels object is at center. That's why the rays are retracing. Are you clear with this? So it doesn't matter how many liquids I can keep. Clear with this? Clear, no? Same thing. Suppose if I put a slab here, this is x is equal to 0, this is x is equal to t, and let's say refractive index mu is equal to 1 plus x by t. Else I'll do one thing, I'll give you some numbers, 2 centimeters and 1 plus 2. Right, object is here and observer is here. Find the apparent shift. Find the apparent shift of a slab. Hope you guys remember the general formula. Comes on, everyone. Apparent shift will be thickness of the slab into 1 minus mu medium by mu slab. This is the general formula when mu is constant. Now here mu is messed up. How do you handle this? क्यों नहीं रहा ना? You will get a ln में आएगा answer. You have to integrate. You can't take average. That mu is in the denominator. I think you're getting confused this with the path difference. You guys remember the path difference का formula? It will be mu d. There you could have said it's a linear function and finished it off. Here it doesn't work. Let's see. So at a distance x, we take a thin slab dx. So that small shift will be thickness of the slab, which is dx, into 1 minus 1 by mu. Outside is vacuum. This is dx, 1 by 1 by 1 plus x. Integrate this. Limits will go from 0 to 1 and 0 to 1. That will be 1 minus ln 1 plus x. Limits will go from 0 to 1. 1 minus ln 2. Clear with this? You have to integrate for each section and then add it up. Did I give, I gave 1 plus x. Okay, I gave x 0 to 2, na? Ln 3, na? 2 minus ln 3. Clear with this? In this, there is one more question. I hope you remember this. Let's say we have a container filled with liquid. There is an object here which is going up with V1. There is an observer here who is coming down with V2. And this liquid ka surface is also moving up with V3. Find the velocity of the object as seen by the observer. The refractive index is mu. Outside is vacuum. All are moving. The liquid surface is rising, object is moving, observer is moving. So if you ask this observer with what speed is the object is moving, what will they say? Let's see. Now here, start like this. Let this distance be x. Let this distance be y. So forget about v1, v2, v3 for now. Let's find the apparent distance. So light are coming from the object. So I hope you remember how to do this thing. Like if a person is standing here, what is the apparent depth? He will, if you ask him, he will say x. If you just take him outside the water, he will say x by mu. So the apparent distance, remember that formula, right? H by mu observer into mu object, that is valid only for the interface when you just cross the interface. So the observer will think the distance is x by mu plus y. Is this clear? So this person will think object is at a depth of x by mu plus y. Now when you differentiate this, we get velocity of the object will be 1 by mu dx by dt plus dy by dt. Now most people think only x is changing, but what they forget, y is also changing. What is x? X is distance between the interface and the object. What is y? Y is the distance between the observer and the interface. Are you clear? So now in the formula, what is x? X is a relative velocity. So 1 by mu. So you tell me, is v1 increasing x or decreasing x? When object is going up, is x is increasing or decreasing? X is decreasing, so minus v1. When v3 is going up, is x increasing or decreasing? Increasing, plus v3. dy by dt. When v3 is going up, y is decreasing. When v2 is coming down, y is decreasing. So this is minus v2 minus v3. Are you clear with that? So you need to check the velocity, whether it is increasing x or decreasing x, or increasing y or decreasing y. Clear? It's 1 by mu. Check it out. Observer is outside, so light rays are going from water to outside. So this is another way to play around with this. You can have multiple surfaces. Do check out the formulas. So before going ahead, let's do one problem. So let's say we got a slab here, mu is equal to 2. This is 2 centimeters. And then let's say we got a lens here. Focal length is 20 centimeters. And then let's say we got a mirror here. Object is here. This is 31 centimeters and this is X. Same story. Find X if the final image is on the object. Slab, lens, mirror. Brute force it. Just have to keep solving. Yeah, 60 and 80. So first thing, the shift. 2 into 1 minus 2, 1 centimeter. So the lens will think the object O dash is actually at 30 centimeters. So if you try to draw the ray diagram, it looks something of this sort. When you extend them, it feels like rays are coming from O dash, which got shifted by 1 centimeter. Remember that the image will always shift in the direction of the light rays. So this guy will create an image. That formula, 1 by V minus 1 by minus 30 by 1 by 20, that will be 60 centimeters. And then you know the process. There are two cases. Either it can be at the pole or it can be at the center. Clear with that? So after hitting the lens, the final image which forms, if it falls on the pole or if it falls at the center of the mirror, the light rays will retrace. Clear with this? Let's see if you remember this. We are not doing optical instruments today. That we kept it for separately mains portion. We'll be only doing till basic prisms and the other stuff. So light ray is entering PQ. What angle we don't know. It hits PR. That's an angle slightly greater than critical angle. The word is that. So basically it behaves like a mirror that it hits QR and comes back with alpha. Alpha is 30 degrees. He's asking find the refractive index of the prism. Get this. You can't use any of the prism formulas. The prism formulas are derived under the assumption the light ray goes and comes out from the other surface. If there is a TIR, it is not your standard prism cut results. So this is just refraction, Snell's law. 7. That looks right. Let's see. We just have to draw the picture. Now he said this is angle slightly greater than critical angle, so this will be theta critical. This is theta critical. This is theta critical, just slightly greater. This is 30 degrees. This is I. This is mu. It's an equilateral prism, so this is 60. This is 90 minus theta critical, and this is 90 minus I. The 90 minus theta critical plus 90 minus I plus 60 is equal to 180. I plus I is equal to I plus theta critical is equal to 60. If you apply Snell's law, mu sin I is equal to sin 30. And we also know sin theta critical is 1 by mu. This is mu. This will be sin 60 minus I is equal to sin 30. Mu will be this. This is 60 minus theta critical. So this is sin 60 cos theta critical minus cos 60 sin theta critical is equal to half. Take that mu, substitute here. Yes, solve this, you will get x is equal to 7. Clear with this? You just have to expand it there. You get the sin a minus b, you need to expand that. Clear with this? A little bit of a geometry and Snell's law, there's nothing there. That's how an integer question will be. Let's say we got a slab. Inside the slab, we got a prism. This is 4 degrees. This mu is 3 by 2. This mu is 4 by 3, and this mu is 4 by 3. Outside is vacuum. You're sending a light ray like this. Find the deviation. Thin prisms, huh? 4 degrees is a thin prism. Hope you remember the formula for thin prism deviation. Delta is a into mu minus 1. The light ray is coming from vacuum and goes into the vacuum. Just to show you, suppose if you have a thin prism, this is mu prism and the surrounding is mu m and surrounding is mu m. So if the whole space is surrounded with mu m, for this delta is given by a into mu prism by mu medium minus 1. This is the formula when the light ray comes from mu m and goes into mu m. You can't use that formula here. Vacuum, medium, prism, medium, it's messed up. Clear with this. This formula is not valid here. So basically, mu m will be 1 actually here, if you think about it. Initial ray and final ray are in vacuum, not in the medium. This formula is valid. So here ray enters from mu m and leaves from mu to mu m. You have to give me delta upward, delta downward, that also. How do we handle this? Others, you need to keep your cams on. If your cams are not on, you'll be removed from the classroom. See, how do we do this? Let's split the whole thing into pieces. So I got a slab, 4 by 3. Then this thing now, I will treat this thing as a, like this, a prism. This guy will be 2 degrees. Then this is the 4-degree ka piece. This is another 2 degrees ka piece. And again, this is a slab. Clear? Can I do like this? And parallel slabs do not create any deviation. Remember, when a lighter enters a parallel slab, it goes away without deviation. So basically, this guy, ka deviation delta will be 2 degrees into mu minus 1, which is 4 by 3 minus 1. That's 2 by 3 into 2, 4 by 3 degrees downward, upward actually. Because if you have a prism like this, it'll push it down. If you have a prism inverted, it'll push it up. This guy also will be 4 by 3 up. This guy will be 4 into 3 by 2 minus 1. That's half. 2 degrees down. So net deviation you can simply add up 4 by 3 minus 2 plus 4 by 3. That is 8 by 3 minus 2. That would be this is 2 by 3. That will be minus 2 by 3. So minus indicates down. Clear with this? There, they can play like this with the thin prisms. So you split this into parallel slabs. Clear with this, everyone? So that is one way to play around with this. Let's see, you remember this? So we got a glass sphere, mu is equal to 3 by 2, and here we silvered it. Radius is r. Object is here, and this distance is also r. Outside is 1. Find the final position. Find the final image. So remember, light rays will hit refraction on curved surface, reflection, refraction, total 3 phenomena. A little lengthy. There's a little work. Hope you guys remember the refraction formula. So for the first refraction, mu2, what is mu2? The refracted medium. That is 3 by 2 minus v minus 1 by u, which is minus r, is equal to mu2 minus mu1, 3 by 2 minus 1 by r. This will be 3 by 2b, this will be 1 by 2r, and minus 1 by r. That would be minus 1 by 2r. This image is actually virtual. That's mu1 by r. Interesting. 2 will cancel. V is equal to minus 3r. Got the same? So this object which is forming here, if you take this as object, the light rays are going like this. It is 3r. So the mirror will think the light rays are coming from. So this is your first image. So remember, this distance is 2r. This is 3r. So this will be 5r. Clear with this? So mirror will think the object is at 5r. Now use mirror ka formula. 1 by v plus 1 by u is equal to, it's a concave mirror, 1 by minus r by 2. This will be minus 2 by r plus 1 by 5r. Numbers are bad. This will be minus 5 to 10 plus minus 9 by 5r. The light rays will hit and the image will form here. This is your I2 and this is 5r by 9. Again, we use reflection on curved surface. This will be I2 and this distance will be 5r by 9 and this distance will be 2r. Numbers are bad. Then again, we'll have a refraction on curved surface and they'll get an image. I'll leave it to you. I should have given mu is equal to 2. But got the steps? You just keep solving that. There's nothing there. Matlab refraction ka formula, then reflection ka formula, then refraction ka formula, and so on. Clear with the steps. Similar one, but what if we have a lens and this is silvered? Object, let's say mu is equal to 2, this is r, and this is 3r. R is equal to 10 centimeters. Find the final image. So one side of the lens is silvered. Combination of lenses and mirrors, remember? Try. Give a minute or two. This is an important one. Comes a lot. Let's see. So we treat this thing as a lens, a mirror, and a lens. Right. So first find the focal length, 1 by f mu lens, that's 2 minus 1 by 2 by 10. So that would be 1 by 5. So power of the lens will be 5 centimeter. Hope you remember 1 by f in meter. So that's 20 diopters. Power of the mirror will be minus 1 by fm. Always, try to add the powers. Don't use 1 by f1 plus 1 by f2. If there are only lenses, it works. But if you have a mirror in the middle, the minus sign will mess up the whole thing. So here the radius of curvature is 10. So this will be minus of minus 5. That's also 20 diopters. So this power of the whole system combination. And remember, this whole thing behaves like a mirror because the light ray is getting reflected backward. Is 2 times power of the lens because it passes through the lens 2 times and one mirror. That's 20, 20, 20, 60 diopters. And power of a mirror is 1 by fm. So focal length of the mirror is minus 1 by 60 in meters. So that's minus 10 by 6 or 5 by 3 centimeters. That means this whole combination is behaving like a mirror of focal length minus 5 by 3. Minus meaning it's a concave mirror. Where did you keep the object? 30 centimeters. Okay, this just becomes simply a mirror question. Now use the mirror formula. That's what I'm saying. If you don't know what kind of thing it becomes, the formulas will get messed up. And 1 by f will be minus 3 by 5. Solve this, you'll get the answer. Clear with this? So you can, that's a lens, mirror, and lens. So you can actually assume a thin air gap here and you can do that, it works. If you don't want to do that, then the problem is you have to use refraction on curved surface, mirror, refraction on curved surface. It becomes unnecessarily big. Don't do that. Clear with this? In lens displacement method, this is the one of the experiment we have. Height of the images. Do you guys remember the experiment? Is 9 centimeters and 4 centimeters. Find the height of the object. Should definitely know what is the experiment, especially for advanced paragraphs, it will be useful. Yeah, most of you got it. You know the formula. Height of the image will be root h1 h2. 6 centimeters in this. That's it. Straightforward thing. If you know the result, you're done. But what is the experiment? We have an object, we have a lens, and we have a screen. The distance between them is capital D. So you adjust the lens in such a way the image forms on the screen. This is the first position. Then you move the lens a bit. Object is still there, screen is still there, nothing changes. And you'll observe again the image falls on the screen. So there are two positions when the image falls on the screen. And this thing moves by a distance small d. The reason why this happens is because initially this was x, this was y, then this becomes y, and this becomes x. X and y are interchangeable. Right? And then when you solve this thing, x plus y is equal to capital D, and then 1 by v plus minus 1 by minus x is equal to 1 by f. Two equations, two unknowns. You solve this. This is actually an experiment to find the focal length of a lens. Do you remember this? So from there we get the focal length formula. F is equal to d square minus small d square by 4 capital D. This itself will be a question in the exam. They will say in a lens displacement method, the distance between object and the image is some 30 centimeters. When it is moved by 5 centimeters, the image again forms on the screen. Find the focal length. Now, if you don't know this, you're gone. It's fine if you don't remember the formula, remember the experiment. You can derive this in 1 or 2 seconds. So that is one formula. This experiment also tells you something, that capital D should be always greater than equal to 4f, or else this experiment won't work. The minimum distance between the real object and real image is 4f. Another thing, the product of the magnification in both the cases is 1. The fourth formula is that only height of the image will be object is root over h1 h2. The reason is this. Here the magnification will be y by x. Here the magnification will be minus x by y. So when you multiply, you get the product is 1. Clear with this? This is one. There is another type of questions. Most people goof up this. We have a concave mirror. Let's say radius is 20 centimeters. Height of the image is twice the height of the object. Find position of the object. Simple one, but there is a certain mistake people do. I just want you to be careful with that. Let's see what will you do. How many answers are there? There are two answers. That's the first thing you should realize. I simply said height of the object images 2 times. It could be real or it could be virtual. That's the first thing you need to realize. Second thing, this is the mistake generally happens. So let's say this is the image, the object, and let's say this is the image. So when you write the things, distances, don't write u and v. This is the mistake generally happens. Always be careful. Always write the distance as x and distance as y. If you write u and v directly, the whole thing will get messed up with the sign convention. Clear? So now when you write for this case, what will you write? 1 by v plus 1 by u is 1 by f. So here the focal length will be minus 10 centimeters, sign convention. So this is 1 by v, this is 1 by v minus of 1 by minus x is equal to 1 by minus 10. And here what is the magnification? Magnification is minus v by u. Because it is inverted, it is minus 2. Now this is what happens. If you don't take x and y, people take this as u and v, right? So in this case, luckily you will still be saved because both are minus. But in the virtual case, the sign will get messed up. So here this will be minus of minus y and minus x. This will be y is equal to 2x. Clear with this? take this, substitute, you'll get extra value. So just keep this in mind. Whenever they say object is there, image is there, never write as u and v. Always take x and y, then substitute in the sign convention. Now for the second case, the object is here and this is virtual. So in this case, magnification is +2 and minus v by u. This is x and this is y. Now if you take this as u and v, again you'll mess up the signs. So now when you write the formula 1 by v plus 1 by u is 1 by f. So here this will be plus y, u will be minus x and f will be minus 10. And this magnification will be minus v by u, which is 2, v is y and u is minus x. Clear with this? So distance is always taken as x and y. That's it. That is the main thing I wanted to show you. And there'll be two answers. Never write the distances are u and v. Clear? Keep that thing in mind. And one last one. We can do more, but I should go through the notes. We have a lot more varieties in that. Focal length is f. This also we did in the class notes. This is a good one. So we have a parallel beam here for axial rays. And this lens is there. Now, if suddenly you start rotating this lens with omega, find the velocity of the image at this instant. Well, let's make it simple. Let's say if you rotate this lens by theta. Find the displacement of the image. Hope you remember this. This thing came in 2006 when I wrote the JEE exam. I messed it up. Find the displacement of the image. The concept is pretty good though. I got the answer, but I couldn't do the approximation. So yeah, still. For small theta. That was the actual question. Remember what was the concept here? The idea was this. So initially, if the light beam is coming parallelly, the image will form at the focus. I'm just more keen on this. How do you trace the images? Now, when you tilt this, the principal axis also will get tilted by an angle theta. Fair enough. Now, the light ray which is passing through the optical center, that will go undeviated. Ray through optical center is undeviated. That will just go straight. That is one. Second thing, what will the lens think? The lens will start thinking now, the light rays are coming from somewhere here. So it will think the object must have got elevated. That's what it feels, meaning I know it is very far. Then from this logic, if this is O dash, then the image must also fall on the focus, isn't it? Image must fall on the focus, but somewhere perpendicular to this line because it is elevated. Is that making sense? So if this was focus, the image should also be somewhere on a line perpendicular to the principal axis and passing through the focus. Make sense? So this image must lie on that undeviated light ray. The image must also lie on a line perpendicular to the principal axis and passing through the focus. This is the intersection. So this is the image. So the best thing is this: the image will actually still be horizontal only. It will shift only front and back. It will not rotate at an angle. And once you got that, you're done. So this distance is f. This angle is theta. So this will be f sec theta. Initially, this distance was f. So the displacement will be f sec theta minus f. Clear with this? So if I say it is rotating with omega, then I have to just differentiate this. D theta by dt will be omega. I can find the speed of the image also. Are you getting the concept here? When you rotate it by theta, the light rays are coming from a certain height. That's what the lens will think. So it will also try to create an image above the focus because the image is still, object is very far. But still, you need more detailed explanation. You should definitely check it out. It's a pretty good question because most people will think the image will start rotating. It doesn't. Yeah. So check it out, 39. Okay, that's a bit about ray optics, right? Like I said, at a mains level, there's really not much. You just need to remember all the formulas, right? Mirrors, plane mirrors, and then you have spherical mirrors, and you have refraction on curved surface, Snell's law, apparent depth ka formula, then refraction on this thing, what do you call it? Slabs, and then we have lenses, combination of lenses, prisms, and then we have that dispersion and ray optical instruments. That last two we will be doing it later on. Okay, with that we'll wrap up for the day, right? So make sure to go through the whole stuff again and continue solving, finish your PYQs and everything. And we'll catch up on Friday. We'll see, maybe we do one or two more questions, and then we'll start off with vectors, kinematics, and NLM, I guess, this week. Mechanics is starting. We will do that. And Saturday, we also have a PTM, right, at 9 o'clock. It's just a general session, like, what is the plan now, how things are going on, and roughly all that stuff. So, yeah. So I'll see you guys again on Friday. So any doubts, anything else, you can stay back or else you're free to leave.